Hi, welcome back. So up next we have microservices testing at scale with Kishore and Sindhu from Discover. They're going to be talking about how our card acquisitions team at Discover applied different testing techniques to test and deploy microservices changes rapidly and safely multiple times a week. So excited about this talk. Testing is so intimidating. Go ahead and take it away, Kishore.
Hey, thank you. Thank you all for attending today's session. This is Kishore Kota. I'm a senior architect for card acquisition team at Discover, and I have Sindhu Nair with me. She's a principal architect working with me on the same team. Today, we're here to talk about testing approach in card acquisitions and how we achieve speed with testing microservices. To give some context on what we do, my team is accountable for entire card acquisition application process, which includes multiple end user facing systems, call center systems, and a whole lot backend to support the workflow and rules engine. All of this is actually supported by PCF, some apps that are deployed to PCF, some are in the legacy WebSphere, and also mainframe. I hope you'll find the information shared today is useful and have something to take away. Here are the topics that we will be going over in today's session. As we all know, software testing is the most critical concept of product engineering. Having the right amount of testing at the right amount of time is very important and critical to have a successful release. And it has been a challenging task all the time. For card acquisitions, that balance required us to completely change how we test, literally upside down. Before, more testing was done at the late stage of the release cycle, thus requiring any small changes to go through a full round of regression test and end-to-end test again. Now, our focus has been on testing at every stage of the deployment using various different test automation frameworks, which run with every code change. This dramatically increased the speed of testing, and we were able to fully do automated deployments. This shifted our old testing totally upside down and aligning with modern testing principles. Before we get into the details, let's take a look into how monolithic systems are compared to microservices. A monolithic system usually comprised of very few components and often everything bundled together. In this case, testing cycles are longer. That is mainly due to each change requiring a thorough end-to-end test, which is very expensive and slow to run. On the other hand, microservices environment consists of a lot of moving parts that are responsible for various different capabilities. These typically have a lot smaller development cycle compared to monolithic systems. To achieve the speed, the testing need to be quick. One of the main advantages with microservices is that any newly introduced changes have a lot less blast radius, thus having a smaller test surface area. But microservices pose different types of challenge compared to the legacy systems. How much testing needed? And it can get very complex to identify the right amount of testing when you have the business functionality decomposed into multiple different components. Overall complexity of the system is higher in this case. When testing, main focus should be on the boundaries. It allows to create clear separation and goals. If you need to achieve speed, have a clearly defined test stages and have clear outcome and optimize overall testing workflow. Use lightweight tools. That's very important. And we need to have a good test coverage at all levels. Let's take a look into how the testing is done in card acquisitions. Many of you are familiar with the concept of test pyramid. This is a concept that represents the amount of testing that goes into the artifact when promoting through different stages. This diagram represents a detailed view into different testing stages and the order how they get executed. This metaphor tells us that you need to have a solid foundation in the early stages of the test cycle that is quick to run and provides immediate feedback. As you go up in the pyramid, those are more expensive to run, needs more resources and time consuming. For example, a Selenium test suite that's running a UI test, they take a lot of time to run and requires real working environment. We need to run those only when needed. Let's take a look at the different stages in detail. Unit test. This is a very powerful concept that is going to allow us to get quick feedback. With the current tooling and frameworks we have available for mocking and stubbing, you can essentially unit test everything. When writing unit test, follow good guidelines around establishing well-written test naming. Make sure these are fine-grained and focus on validating a piece of code in isolation. You need to make use of mock, stubs, and spice to achieve the intended behavior. Test case validation should be focusing on both outcome and expected behavior. To give a simple example, if you're writing a unit test, you're going to start about the dependency execution. It could be another class that you're calling or another API that you're calling. We have to make sure that we're only validating the piece of code in isolation. And when we do this step out, we can execute the unit test in isolation, but we also need to make sure that whether the dependencies are called with the expected input and with the expected order. You need to ensure that the behavior is accepted as well. And having a good test coverage at this level is really important. Test-driven development gives a good framework for establishing well-written unit test cases. Contract testing. One of the challenges often posed by API providers is that how to ensure any new API changes introduced are not going to break the API consumption that's already there. For this reason, traditionally, provider API changes are deployed to a QA environment. They actually wait for their consuming teams to validate. This typically extends the overall release cycle by a month or two. Contract testing allows API producers and consumers to work in decoupled fashion. A consumer writes a contract for the API endpoint, and the provider actually writes a test against the contract to ensure those contract specs are met at the API level. These tests are run every deploy. That is going to eliminate the need for asking the consumer to validate. One of the challenges that we run into is consumer teams may not necessarily have the skill set to do so. In that case, provider teams write the contract themselves on behalf of the consumer. It's really important to establish the contract, whether it is the consumer or provider writing it. This acts as a tool for provider teams to assess any new changes that they're going to introduce. And if the changes are not backward compatible, they know who to contact. Our teams usually include API behavior as well in the contract. What we mean by behavior is if the API is expected to be called with a different variation of the payload, or if there are any errors or exception scenarios. So we write different contracts. And we use Spring Cloud Contract. This actually produces stubs as well. This will be useful for consumers to mock the API when they're trying to use those in other integration tests. There are definitely other tooling available in the market as well. System integration testing. The goal of system integration test is to ensure system entry points are working as expected and verifying all the integrations that are sitting behind the entry point, which would be any infrastructure interactions or other dependent API interactions in end-to-end flow. We usually perform different levels of system integration tests to achieve specific goals. First one is integration test. The focus here is to validate the API end-to-end flow in a simulated environment, which could be running when you're doing the build locally or when we're doing the build in a CI. Then the next one is consumer integration test. The validation in this case is mainly focusing on the expected outcome from provider. Am I getting the expected payload from the provider API using the established contracts? The next one is dev integration test. In this case, this is a clone of integration test that was previously run, but this time around, it is going to run validation against an app that is deployed in the real infrastructure. This is the time that we will be running the validation against the app that is deployed in the real infrastructure, talking to real database and other dependencies. These practices allow to have a clear goals in each step of the test. A failure clearly identifies what went wrong, and we can have less false positives by leveraging a virtualized environment. Backward compatibility test. So far, we talked about contract testing and API integration testing, those are trying to ensure that the API compatibility between dependencies. But in this case, the backward compatibility test goal is to ensure changes are backward compatible internally within the application, not necessarily at the API level. We follow something called blue-green deployment pattern that actually ensures system availability while releasing a new change. Blue-green deployment pattern is a technique to deploy the new application while the existing app servicing the incoming traffic and flip the traffic to a new system when the deployment is successful. During the blue-green deployment, an application environment will reflect a mixed state. As you can see in the diagram, an app going from V1 to V2, it will have a mixed state where the older application may be trying to talk to the new database. How do we know that this kind of a combination is in working condition? The backward compatibility stage ensures this mixed state is in working condition. We have built our pipeline so that it actually keeps a copy of the production version in one of our pre-prod environment. Whenever there is a new change introduced, it's going to run validation against this production copy of the app just to make sure that the production copy of the app is in a working state with the new database changes introduced. And the general recommendation wise for teams that are trying to rename or delete any of the fields at the database level, we recommend that to be done in a two-step process. So it ensures backward compatibility. This stage is really important for us for two reasons. One is no outage deployments. Two, if the changes can be backed out or not. Performance test. This is an important aspect of the test strategy to understand how the user experience is impacted with each change. It's critical to performance test every change following shift-left principle to detect any anomalies upfront rather than when they become bigger issue. We use lightweight tools such as Gatling and JMeter for creating performance tests. The main focus here is on our system boundaries. Using API stubs and simulations as needed, it allows us to decouple from dependencies and get accurate test results. JMeter and Gatling scripts are executed in CI/CD pipeline with every deployment during one of the stages. We try to keep execution to be short cycle, like 10-15 minutes. We also use tooling for loading synthetic data, like GenRocket, for validating DB performance, simulating production-like volume. In general, we try to achieve 2x peak uses to cover for any spikes in transactions or future growth. Next, vulnerability testing. One of the pain points before implementing fully automated security monitoring is that it's a manual process for our teams to engage a different team and get the feedback after a week or two. The security fixes tend to become a fast follower than addressing them prior to the release. This was creating a lot of back and forth, and not doing shift left is requiring us to establish a remediation process where we maintain a separate backlog and dedicate capacity for addressing them. With the implementation of the contract scan, it actually does the dynamic application security testing. We use some of the artifacts from the previous stages to run against an environment where contract scan is performing dynamic code analysis. The results are available in the dashboard and emailed to the team after a few minutes. Teams are supposed to go back and ensure that any major or critical findings are addressed before that artifact can go to production. We have built our pipeline, some governance stages where it is going to block any deployments that are having a major or critical findings. This is going to be done during the production deployment phase. This ensures the changes deployed are not having any security vulnerabilities. Disruptive test. We want to know how our systems behave and what would be the user experience look like when one or more dependencies are down. We use API simulations or manipulate configuration via CLI to create respective outage scenarios. These can be scripted via shell, or there are frameworks that allow you to inject the simulations like Spring Boot Chaos Monkey. This allows us to create outage scenarios and see how the application is working. If the app behavior is showing any data loss, then teams make necessary design changes to prevent them. This also ensures we have controls in place to address guaranteed transaction processing. Discover being a financial company, we're regulated to ensure we give the same treatment to every customer. Having these tests run in regular fashion with every deployment ensures that the application behavior is intact with every change. Main objective with this is get to a known state with all the possible outage scenarios. Keeping the same microservices API boundary concept is a good practice to establish fine-grained test coverage. We're still learning and maturing in this space. Sindhu will be taking over the slides from here on. Sindhu.
Thanks, Kishore. Hello, everyone. As Kishore mentioned, my name is Sindhu Nair. I'm also an architect in card acquisitions at Discover. As we were maturing our continuous delivery model to a daily release schedule to production, we realized the need for end-to-end user journey testing as part of our production deployment. This ensures that all components of the system are functioning correctly and the critical end-to-end flow of card acquisitions is validated with every deployment. We created a dedicated CCF space for end-to-end tests. This test space is refreshed with the production version of code every morning at 5 using a Jenkins job. Teams who plan to go to production on any particular day deploy their microservices to this space before the cutoff time, which is 11 a.m. And the end-to-end test job kicks off on schedule. The job executes a Selenium script and publishes the results to a Microsoft Teams channel. Teams have to verify the test results to make sure that all the test cases are passed. If not, they have to investigate the reason for failure. And depending on the reason for failure, teams have to address the issue and rerun the failed test cases before they proceed with production deployment. We have 3 levels of end-to-end tests. Level 1 is around 15 test cases with the most critical flows. Level 2 is around 30 test cases and include all the critical flows. And the level 3 is around 300 test cases with all the possible flows. It's the level 2 test cases that we run every day. Teams run level 1 on demand to validate small changes and level 3 when major changes are introduced. Teams add test cases to the test bed as new features or flows are introduced. Next slide, please. Another test that we execute in parallel to the end-to-end test is browser compatibility test. It's important for ensuring customer-facing UI is validated in all the major OS and browser combinations. We use Selenium WebDriver to build the browser compatibility test and cross-browser testing tools by SmartBeard to execute them. This tool simulates different OS browser combinations in a cloud environment. For browser compatibility testing, Chrome on Mac is used as the baseline. When the product owner accepts user stories, they test using Chrome on their Mac. And the CBT tool uses it as the baseline. As I mentioned, this test is executed in parallel to end-to-end tests. Teams also executed it on demand when new UI changes are introduced. We want to identify if there are any compatibility issues as early as possible when new pages are built. Next slide, please. After end-to-end tests, we execute production smoke test. The goal here is to ensure configuration is validated. Validating JWT authentication in pre-prod only proves that pre-prod is working. It doesn't necessarily guarantee that it will work in prod. Same is the case with the certificates, third-party connections, and other network connectivity. This test stage is used for environment-specific validation. We have a dedicated space in the production foundation for running these validations. This stage is also used to ensure production environment is stable to introduce new changes. After this step, we have the code deploying to production. Next slide, please. Now let's see how we are able to execute all these tests on a daily basis. You probably guessed it already since it was mentioned a couple times. All this is made possible by our CI/CD pipeline. This diagram represents the different stages in our pipeline. It shows what tests are done at different stages of the pipeline. For example, the dev deployment stage executes integration tests, backwards compatibility tests, contract tests for all microservices, and contrast security monitoring. Pipeline plays a big role in ensuring the tests are run and are passed. Some tests are executed with every build. Some are executed only after the pipeline reaches certain stage of the production deployment. More expensive tests are run only when teams are going through production. One stage that we didn't discuss is the acceptance test. This stage is for user story acceptance by the product owners. This test is mostly executed manually by the POs at this time. They use Selenium scripts as appropriate. We are working on establishing BDD practices which will automate user story acceptance. We don't have time to go into the details of the pipeline today, but this is a critical component for a successful testing strategy. With that being said, this concludes today's presentation. Hope you were able to learn something useful. If you have any questions or like to discuss something in detail, please join us for the Q&A session. Thank you.
Oh, thank you so much, Kishore and Sindhu. That was a wonderful presentation on such a complex and intimidating topic, and really incredible to see how Discover manages their testing. So up next, we're going to have a break. And also, if you would like to continue the conversation with Kishore or Sindhu in a private Zoom room, make sure to click the link that's in the Slack channel for their talk, join the discussion. And when we come back from our break, we're going to have Craig Walls from VMware. He's going to be talking about modern application configuration in Kubernetes. See you in a bit.